Somewhere in the flat green swamps of central Louisiana, hiding behind a curtain of Spanish moss, sits a low wall of concrete and steel. It is an unremarkable structure, but it spends every second of the day holding back the largest river on the continent. Maps teach us to view rivers as fixed features of the landscape, but that blue thread you trace from Minnesota down to the Gulf of Mexico is not permanent. It is a temporary arrangement. This geographic instability threatens one of the world's most critical industrial corridors. The stretch between Baton Rouge and New Orleans houses a massive concentration of ports, refineries, and grain terminals. Millions of tons of exports and the drinking water for millions of people rely on the river staying exactly where it is. The problem is, the Mississippi wants to leave. It wants to abandon New Orleans, bypass Baton Rouge, and leave 3 centuries of human infrastructure behind. It has no malice toward those cities. It simply wants a shorter path, a steeper drop, a faster road to the sea. If it succeeds, the lifeblood of that industrial corridor would dry up, replaced by a stagnant, salty inlet creeping up from the Gulf. And the only thing preventing that devastation is that single gate hidden in the swamp. A staggering share of the American economy relies on an illusion of geographic permanence, one that is currently enforced by a desperate, around-the-clock standoff against nature. To understand why a river would abruptly abandon its own channel, you have to stop thinking of it as a geographic boundary and start viewing it as a massive volume of water relentlessly obeying gravity. Over thousands of years, the Mississippi drags an unimaginable weight of mud toward the ocean. As it drops that sediment near its mouth, it builds new land, extending its own path out into the water. But every mile it adds to its length flattens its slope. The current grows lazy. The water essentially traps itself in a longer, gentler path of its own making. Eventually, a choked, sluggish river notices a better option. During a massive flood, water spills over its banks and finds a steeper route downhill. The current quickens, carving the new channel deeper until it becomes unstoppable, and the entire river jumps course. Geologists call this violent change of address an avulsion. Looking at the Louisiana coast, you see this process recorded in the land. It's a stack of abandoned deltas. The river once ran east to build the St. Bernard Delta, then swung west to build Lafourche. Each lobe marks a former mouth. Historically, the Mississippi reinvents its lower course roughly every 1,000 to 1,500 years. Comparing that historical cycle to the time the river has spent in its current bed shows the Mississippi has exceeded its expected lifespan. By the geological clock of this landscape, the river is overdue for a change of address. The river has already chosen its next path. It is an alternative route called the Atchafalaya. Map the 2 routes side by side, and the contest is hardly fair. The Mississippi wanders hundreds of miles southeast. The Atchafalaya makes a straight shot south. Covering half the distance means it's twice as steep. Gravity prefers the short, steep plunge every time. By the late 19th century, surveyors noticed something deeply unsettling. Water was no longer trickling from the Mississippi into the Atchafalaya. It was rushing in with growing force, carving the shorter channel deeper every year. The capture had already begun. To stop the economic heart of the region from drying up, the U.S. Army Corps of Engineers stepped in. In 1961, they built the Old River Control Structure to effectively freeze time. Its massive gates dictate a strict legal compromise, allowing 30% of the water to head down the Atchafalaya, while forcing the remaining 70% to stay in the Mississippi. The bargain held until the spring of 1973, when an enormous flood slammed into the gates. Unseen by the engineers above, ferocious underwater currents scoured away the earth directly beneath the massive concrete foundations. The structure came within a hair's breadth of collapsing entirely. Had the foundation failed, the map of Louisiana would have been rewritten in a matter of weeks. The near miss proved that gravity and gradient are planetary forces, and they will violently resist being put on pause by human engineering. The engineers fought back the only way they knew how, with more concrete. They expanded the complex, building an auxiliary structure and turning a single gate into a sprawling fortress spread across the floodplain to share the extreme pressure. While the gates successfully hold the water, they also redirected the fate of the millions of tons of mud the river carries. A free, shifting river naturally spreads its sediment across the coastal marshes, constantly laying down fresh earth to replace whatever the sea washes away. A levied, controlled river acts like a fire hose. It blasts that vital mud so fast and so far out past the edge of the continental shelf that it is simply lost into the deep ocean. The unintended consequence has been devastating. Starved of the sediment that built it, the Louisiana coastline is now sinking beneath the Gulf at some of the fastest rates of land loss anywhere on Earth. This is the quiet, cruel irony of the engineering marvel that keeps the ports in business. To save the cities, we are deliberately sacrificing the very earth they are built upon. The gates at Old River are the largest bet ever made against the forces of geology. But there is a massive imbalance in this standoff. Human engineers must successfully hold the line every single spring. The eternal river only has to win once.